Hi, I am going to talk about Dojo today, which is a on-chain gaming framework built on Cairo. Just first, my name's Loaf. I'm one of the co-founders of Realms, Biblioteca DAO. I'm also one of the co-founders of Dojo. I spend my time building on-chain games, building on-chain tooling, um, and building a bunch of tooling as well with Cartridge. So just to clarify, Dojo since day zero has been community driven and it's always been open source. And we like to describe it as a provable game engine. And it's a provable game engine and it's a comprehensive toolkit for building these games. Now that might not mean anything just yet, but it will. We'll get to it. Dojo comes with a lot of these different kind of tools like Sozo, Katana, Tori, Origami, and then there's some cartridge tools which help you deploy and manage your worlds. So yeah, we built Dojo from our experience with building on-chain games. And so like previously before Dojo, in 21, 22, every time you tried to make an on-chain game, you would have to like roll your own software stack. So you'd have to like kind of design your own indexer, design your own contract architecture, design your own client. And there wasn't really any consistent kind of package that kind of like bundled it all up into like a clean developer experience and offered like a good user experience. And so you basically had to recreate an engine every time you wanted to make a game, which wasn't much fun. And you just spent a lot of time just rebuilding the same stuff over and over again. And so, in 22, like a few of these game engines kind of spawned Mud, Dojo, and a couple others to kind of solve these problems. And we've been iterating since then. So just to clarify for some theory, an on-chain game for new people is really just a game where the state and the logic resides entirely on a public blockchain. And so the whole game is defined by smart contracts. And so it's like a very abstracted from regular game where or maybe a Unity-based game or where like the entirety of the logic in the state is just built within you. With on-chain games, your logic and your state is entirely on this public network, which means anyone can interface with it, anyone can build a client with it, a client to it, which offers up this whole new medium for design. Now, I don't want to confuse people, but there is some context here. And because we're kind of, this is a Starknet bootcamp, and we're building in the Cairo stack, this is worth considering. And provable games is another concept which you may or may not have heard of. It's kind of an emerging topic right now. But a provable game is really like an on-chain game, but it's designed on ZK VM, like the Starknet VM and its execution can be verified because it's written in Cairo and it's written in another ZK language. And what this enables is that instead of having to execute an on-chain game on a public network, you can execute it inside of a ZK VM somewhere, and then you can just verify the trace, like the execution trace, which means that you can push a lot of the computation off from public networks into client-side devices, which then gives you much more computation scope to build games. And so that's what a provable game is. And now we can talk about autonomous worlds. You may or may not have heard about them. If you haven't, I guess there's a lot of other topics you can talk about. But there's a lot of things you can read about it because they're kind of like a hot topic right now. But really, all an autonomous world is it's really just a game. It's a game as a protocol, really, and it evolves as the players evolve, as the players do. And there's no single authority of it. And so if you think of a normal game where like the developer is the god and the developer can push updates and the developer can do as they will to the game, an autonomous world is really meant to be this kind of permissionless protocol that people can build on and it evolves with the players and it has no authority. And so that's kind of what my definition of an autonomous world is. There's probably a few other people that have kind of other ones, but that's a simple way to think about it. And so the best way to think about an AW is like Ethereum itself. Like Ethereum really is an AW. It has like a very minimal set of laws, which is the EVM. And if you abide by the EVM laws, which are its restrictions and what you can do and what you can't do on it, that's its physics. And look what's evolved out of it over the last, 9 years, 8 years. And so it really is a world. And just some other theory is, to me, play is like this constant that throughout human history. And on-chain games are just like another extension of this, like Roman dice, chess, Counter-Strike, mobile games. Now we're kind of moving into this era of on-chain games and autonomous worlds where the game itself is on a public chain and people can interact with it and it can have a mind of its own and there's no single person controlling it. And it's just an extra evolution of gaming right now. And so just some brief history. And I suggest if you're really curious on this, go and check out Dark Forest if you haven't heard about it. But I'm sure most people probably have. But Dark Forest was kind of like the OG on-chain game. It kind of spawned this whole ecosystem. And what was really interesting about it was kind of like a developer-first game, and because it was really the first game to have this idea of putting the entire game on chain and just kind of expose this whole like plugin ecosystem evolved around it and kind of tickled everyone's curiosity about what can be. And it kind of birthed the whole on-chain gaming industry. But why though? And so I don't know if anybody knows, but Vitalik actually created one of the reasons why he created Ethereum was that World of Warcraft devs like nerfed one of his, which is kind of funny. And now we've gone full circle, and now we're building games on it. Yeah, play is the constant for the medium changes, and on-chain games are like they're this whole new way to design business models and play. And I can't stress that enough. These are like on fully on-chain games are like totally different from your Web 2.5 games. And I'd say like a Web 2.5 game is like a Axie or something. Like, just a regular game that has its logic off chain, but it's just kind of using NFTs. Like that's not interesting at all. What's really interesting is when you put the entire game on the chain, you can create these like whole new types of business models. And so that's what you should really be thinking about. And one of the reasons why we do this is because the chain is like a blockchain is really the perfect escrow and arbitrator of like the deciding factor. It's the one truth. And so you can use it as escrow for games where you can do high stakes games. You can do micro payments to like 10 different people when a transaction happens. There's all different ways, we're finally there now with like these super low cost L2s, like Starknet's like a cent transactions. It's crazy. And it can open up whole new business models, which I'll get into. It creates like composability first games. And if you really hit the nail on the head, some of these games are going to be very, very deeply profitable for the developers. There's going to be like very, very deep customer spends on them because there's really no limit. And the current kind of market right now, yeah, are the kind of high people that have a lot of ETH. But I'll just go through some like reasons why we're doing this. One of like the top things talked about is like this idea of composability and mods. And because we're kind of building everything on the same chain, we have this shared state, and it's essentially an open API into every game. And you create this like composer type games, and you also create like a open mod environment, right? Because people can just take your game, they can create a different client, or they can create a different like slightly different version of it. There's a whole new game. And if you think about it, like Counter-Strike and Dota, are two mods of games that are like probably two of the most games of all time. And they were mods. They weren't what the developers originally thought of, which is something interesting to think about. New business models can emerge from this. I've got a couple of examples. So Loot Survivor was this game that we built in the Realms ecosystem, and it's going to be relaunching soon, actually. But what's the actual how the game works, it's like a roguelike game, but that's not the important part here. The important part here is like this is a whole new business model that you can do with on-chain games. It's like you have this singular client, and when someone puts a small amount of value into it, so maybe like $1 USDC dollar or something, you can split those fees between 5 different people instantly as that acts. And so that's the new business model. So in Loot Survivor's case, a percentage of the fees goes to the client developer, percentage goes to the OG developer, and then the rest of the fees go to first place, second place, third place. And you couldn't do that before because you can do this single transaction for like a cent. So this is a whole new business model. Plugins, you can charge people to use your plugins, like in Dark Forest. And then, another big reason to do this is the hardness and high stakes that the blockchain brings. There's no going back in these games, and people really do like that. People want to know when they do something in a game that it's not going to get taken away from them. It's final. And so this is the type of game that on-chain games can deliver. It's impossible for people to cheat in an on-chain game as well. And when we do that, we can transfer value between players easily, and we can create these high stakes games. And so, you can create buy-ins into like a very, very competitive, strategy game. You can back yourself into this game. And it wasn't really possible to do this before. I think this is a very interesting area, which there's about to be a lot of exploration into this. There's a lot of games coming out that are kind of exploring this. And so you can kind of split on-chain games into I like three kind of buckets. There's like short experience, like roguelikes, session-based games with stakes like real-time strategies, Civ-like board games. And then you have like the autonomous worlds, which are like these persistent, forever evolving things, which don't really exist yet. They're kind of like a big idea. We'll probably see them in the future, but no one's really nailed them yet. And so short experiences are like low cost, easy to pick up and play roguelike daily puzzles. They got a baked in token loops. And I suggest anybody that's actually wants to go after this boot camp, start building a game, try to do this first. From experience, I tried to build Civilization 6 on chain as my first game, which wasn't a good idea. But this is the best place to start if you're going to go down this road. Some of the examples you can look in the wild. There's Rio, Roll Your Own, Loot Survivor, Paved. There's a bunch of others in the Dojo ecosystem. Just jump into the Discord. And then there's the second type of game, which are these sessions. That's what wrong, but session-based games like real-time strategy games. You know, asynchronous kind of longer games that might go for like 2 weeks, like a Travian style game. They're multiplayer. You know, basically any game that like has an end, but it's multiplayer. That's how I like to consider these. And so some of the ones in the wild right now are like Eternum, Skystrife, Paved, Duper, Dark Forest, Sea Conqueror, Primodium. Some of those are not Starknet games, but they're good case studies in on-chain games. So they're worth studying. I think these type of games are gonna are probably gonna have the highest potential in the short term. Because everybody's competitive and everyone's slightly degen in this space, so they kind of want to bet on themselves or bet on other people. And so this is the best way to do it. There's some of the games. And then there's autonomous worlds, which are these self-governing kind of protocols that no one owns. I don't think really any of these exist just yet. So there's like some glimmers of ones in the market, but no one's really nailed a sustainable one. But someone will, and it will become huge. And it's worth experimenting to try to get there. But I think the only way that they're really going to exist is they need to start in the right scope. They need to like start in the right way. They can't start as they need to start very cleanly. That probably doesn't make sense, but well, maybe we'll get to that later. Yeah, I thought this was a pretty interesting and pretty real meme that I was looking at the other day when he's designing a game. There's all these like dead branches that you take when you design a game, and then eventually you become an autonomous world, and you'd have no idea where you're going to go after that. But yeah, now I'm going to go into that was kind of like my overview of on-chain games and the current market. It was pretty brief. Is anything people find interesting in that, or they want to talk to me more about it, or they have an idea for a game? Just you can DM me. Yeah, Dojo was built to really enable like the creation of these games and to like speed up the development. That was really its like goal. Before it took like 2 weeks, 3 weeks to like add a feature to a game. Now with Dojo, it takes like a couple days, maybe even a day. It standardizes the developer experience of building on-chain games. So if you know how to build one Dojo game and you want to go and mod another game, you'll understand it straight away because it uses the same step stack, which we think is really important in this kind of like composability first world. And it enables the kind of another big kind of feature of it is the way state is stored in Dojo is through models, which are SQL tables essentially, and it standardizes it all. So you don't have to think about how you're going to structure your state within a contract, which is always kind of everybody does it a bit differently every time you make, and so Dojo standardizes that. It also brings a bunch of developer tooling to kind of improve the experience. And most importantly, it minimizes your boilerplate code so you don't have to rewrite stuff. And so there's a bunch of macros that you can use to reduce the amount of code in your games. And so Dojo works by it extending the Cairo compiler, and we inject macros into the compiler. And so you can just write these little shorthand functions, which we'll get to, which saves you time and keeps your code. And so the architecture of it is you can consider like everything in Dojo within like this like world contract. And so the world contract is this contract that you don't touch. It just and within the world, there's like a reference of your models, and there's a reference of your systems and their authorizations to one another. And everything just exists within here, and everything's stored in here. And you can query it for your state whenever you need it. And this is the kind of overall architecture. If you're curious about like go deeper into this, you could have a look at there's more on this in the Dojo book. And also if you're want to have a look at the code, go and have a look at the world contract code. Yeah, so the world provides an interface for systems to interact with and your contracts to compose with. You register on the models in there, and the access controls. And so you guys would have seen this in the past few weeks, struct or Cairo struct. And so this is a Dojo struct, and we call these models. And so within a model, it's how you store your state in your game. And so you can kind of think of it as a key value store. And so the key is what gets hashed and is what you use to reference your model in the database. In this scenario, the key is the player address, and we're storing the remaining moves and the last direction the player took, and those are the values. And you can see we need to add like an attribute Dojo model above the struct, which tells the compiler that it's a model. And then when it compiles, it will do all its all its stuff with it, and expose it and deploy it into the world. And so this is all you need to do to define your state in your world. It's just lots of these models. And then this is the macro that I was talking about. And so this is what we inject. So the get macro is just get exclamation mark. You pass in a world, you pass in a key, which is the player, and then you pass in your models that you want to fetch. And then this little command returns the position and the moves structured information, which was this, in your contract. And then you can do what you want with it. But this, you can imagine this gets expanded out into like a big interface query. But when you write with Dojo, you just write this little get command. So it keeps everything clean. You don't have to rewrite all those like big clunky interfaces everywhere. You just write get. And same with set, like this sets the state in the world. Just by doing this, you can imagine this expanded out into a bunch of queries and a big interface call. But you can just do it as a set macro. You combine all these little things together, and you can massively speed up your development. And then the other part of Dojo is like the Dojo contracts. And so Dojo contracts are like, you would have seen this as well. This looks familiar because you'd normally have a StarkNet contract, but with a Dojo, you define it like this, a Dojo contract, and this denotes that it is a Dojo contract. And then the compiler injects some things into it to enable fast development time. Some of the other features that Dojo supports, like it supports arrays in the models. There's byte array support, indexing events, and so there's another emit macro, which I didn't show, but you can emit events easily. It also automatically bitpacks your models when you write them into the optimal. There are some limitations to it, but it mostly, if you structure them correctly, they'll automatically get bitpacked and compressed, which is very cool. You can install the toolchain just like this. Just go to dojo.com and you can copy it. And we're going to be looking at the Dojo Alpha 5 for anybody that is going to be hacking along. Yeah, so install that. And then there's the rest of the toolchain here. There's Sozo, Katana, Tori. You get used to these names. But Sozo is like a command line tool, and you run it, you get all these potential completions that you can do. You can get accounts, you can migrate, you can clean, you can test, all this stuff. And then there's Tori. Tori is like our automatic indexing. And so if you remember, I was talking before about like how annoying it was to like have to write your own index. Tori kind of solves all that. It just abstracts away the need to write an indexer. And because everything's structured in these models, the indexer knows how to format it. And then when action happens in your world, the Tori captures it and then exposes it via GraphQL or gRPC, which then you can consume and which is really helpful. Like this is probably one of the biggest speed ups out of the whole entire Dojo stack. This is a single thing because you don't have to write any annoying indexer code. You just go Tori up and it's there. And so GraphQL, gRPC. And there's also Katana, which is also part of the stack. It's kind of a local sequencer just for running these games. And it's very fast. And there's Origami, which is another part of the stack, which is kind of a gaming library of Cairo examples. So check that out. It's got maps and random numbers and other math stuff in there. But yeah, really Dojo is like very much BYO client. And so we have like an official JavaScript package, official Unity, official C. Godot is coming soon. Unreal Engine 5 will come soon. If anyone is actually interested in contributing to those, reach out because we are looking for people to kind of spearhead them. Where we're focusing on the kind of lower level ones right now in Unity. Okay, so I've purposely made this example like extremely basic because I didn't know the scope of like people's kind of skills. But I think what I would like everybody to get out of this, if you get nothing out of it, or if you get one thing out of it, is just understanding models, understanding systems, and understanding the macros, and then how we can execute in a client. So I'll go through some of the toolchain first. And since we are going to be, we're on the alpha build because this is it's the latest build because we have to be. You do Dojo up dash v and then the version, and it'll install the toolchain. And now we're ready to go. Here's the book link. You can go and check out. We're kind of in the middle of we're on the march to version 1. And so there are a few things in flux, like some of the stuff in the book. So if you do find any, typos or discrepancies, just either propose a PR or flag it as an issue. But yeah, as I said, Dojo is it's an open source organization. So, and we are looking for more contributors. So if you think yeah, please contribute. So we got that installed. Now, what we want to do is we're going to go to our contracts and we are going to, actually, we'll just look at some code first. So this is my contracts directory. I kind of like to split everything into these into systems and models directories and the tests. There's other developers that like to do different things, but this is the way that I like to do it. And so we can start with the models. And so what we're building here is, oh, hang on, I'll just flip to just going to quickly go through this. So what we're going to build is we're going to build this tiny little like app where you can click a square and it changes to red or blue. And this could be, you could take this app and turn it into like a full-blown game, but we're just going to keep the scope minimal and focus on a couple models, a couple systems, and it's connected into the client in as few bits of code as possible. And so what we need is we're going to need a tile with X and Y keys, and then we're going to need a player with an address to register the player. And the tile will have a color, and that's it. And so these are the two models that we need. I like to, for reference, if you are going to build a game, I highly recommend paper prototyping the whole thing in Figma first and even playing it through, because you'll probably find that some of your mechanics don't work or you don't like them. And it's better to find it out in Figma than find it out after you've spent a week writing it in code. And then we're going to need two functions. We're going to need a place tile and a register player. Actually, it's going to be a paint tile, and we'll call this spawn. These are the things we're going to need. And then we're going to might need some functions, the check can place tile. So that's what we're going to need to build. So I've got here. So I'll just type it out because for fun. So we're going to get a struct. My Copilot does it for me now. But so what we've done here is we've created a player struct. It's a Dojo model, which I have to find with my attribute here. That's all you need to do. And then I've defined it with the key as the address. And so if you remember, the key kind of denotes how I'm going to fetch this in the future. And so I'm going to use the address of the caller to fetch this model. And then I've just created a little implementation which works with the structs. And it's a very clean pattern to write some repeatable logic in the traits. I really like doing this. And so that's our player model. That's really all we need. And then we've got a time between actions constant. So we'll get rid of that. The other model we need to do is a tile. And so the tile actually has two keys in it. And so when you put two keys to denote a model, this creates a compound key. And the compound key is a hashed key. Same like in Solidity and stuff. So this means that I'll pass in an X and a Y, and then I'll get the color. That tile is pretty simple. So those are the two models that we need. And now we're going to write the system. And so I've got everything here in this actions contract. And so you can see it's a Dojo contract. I've just created this actions contract. I've imported my models. So this is all standard stuff. This is like what you guys have been doing for the last 6 weeks in Cairo. So there's nothing new here. I am first going to get the address of the caller. Simple. Then I'm going to get the world. I'm going to get a unique ID from the world. And so now this is one of the unique things that happens when you create a Dojo contract. It kind of injects this world dispatcher references, and you need to have the world dispatcher as the first parameter in a function as practice. And what we're doing here is we're just going to get the UUID of this just creates a unique ID. So that's all we're doing. And that's a built-in Dojo function. And then we're going to get the existing player. But there's a bug here, actually. because I think I changed this. This is actually meant to be that because that is the address of the player. And so we're going to get the existing player with the get macro. We're going to pass in the key, which was, if you remember, the address. So you have to put the key. You put the keys in this part of the code, and then you put in the model which you want to fetch. And so that will fetch the existing player if one exists. And so then I just check that the last action is zero, because if it's not zero, it means they already exist. And then I'm going to get a new timestamp, and then I'm going to set that model in the world by doing this macro then. And so I just do set, pass in the world, pass in the model, and we're good to go. That's all we need to do. And so that in this small function, we've checked it if an existing player, if the player is already existing, and then we just set it. And that's all we do. Pretty simple. And then we're going to do another function which is called paint. And paint is just going to get the player, check that the player exists, and it is the player that's calling. And then we're just going to set the tile with the X, Y, and color coordinates. And that's all we're doing. And so we can just do, and so you're going to get used to using these command line tools. And so I just built that then. Everything went fine. And I can sozo test. Everything went fine. We'll have a look at the tests quickly. And so these tests, I mean, it's just like a regular car test, but we have a few extra like utils that you can use to kind of build out your testing suite, make it a bit easier. And so I've just created a setup helper function here where I spawn the world. This is a helper function. And I just pass in my model class hashes and it deploys the world for me. And then I also have to deploy each contract system that I want to deploy. And so I'm just deploying the actions system here. And then I'm just, returning both. I do a similar thing here with the spawn. I am just getting the setup function. I'm setting the caller address, and then I'm calling spawn, the spawn function itself, and then I'm just returning both. These are just helper functions, and same with the place. This is a helper function, and then I just test the spawn. And in my tests, I can use the gets as well. And so these are helpful for checking values. So you can use the macros anywhere in your app. And then I do the same thing with place. As I said, this is a pretty basic app. So yeah, that's most of your Dojo worlds are going to be built with these in these two ways: models and systems. There's an awesome Dojo repo, which has a whole bunch of like kind of big projects baked in there. One of the games that I'm working on is called Eternum, which is a gigantic game. It's basically Civ on Chain. I know I said I didn't build Civ on Chain. I tried to build Civ on Chain as the first game, but now I've gone back and I'm actually trying to do it. And there's like 5 of us working on it. And it's a huge Dojo world with like 20 systems and like 20, well, more than 20 models. So go and have a look at it. Also, it's got a 3D client and everything connected, so it's pretty crazy. But yeah, this is where you should start. And so when we've done this, my font's quite large now, but I normally do this. And so to spin up a local kind of test net, I mean, you guys might have used Katana before, or you may have used like the DevNet. I haven't used that in years, but there's the StarkNet DevNet. So Katana like replaces all this for local development, because the most important thing when you're building a game is like trying to get to like a playable game as fast as you can. Doesn't matter how bad it looks, you need something that's playable. And so to spin up a Katana, you just do this. You just do this command. And now we have a local Katana up and running on my network, exposed at 50/50. And so you can guess what we do next. So we've already built our contracts just before, but we'll build them again. And so sozo build just compiles and builds. And so then now we just do sozo migrate apply. And so what this is going to do is this is going to take my compiled code and it's going to deploy it on my Katana that I just deployed. And so you can see here, it's running, it's executing, it's setting everything in there. See, it's installing my models, installing my singular. Yeah, so that's done now. That is the Dojo world deployed on Katana. And it's giving me this world address. And so what I can do now is I can go Tori -- world and my world address. And I have to include allowed origins as well, because you can change your cause settings easily. And I'll spin that up. And now Just ignore those errors. They're just IPFS errors, but they're not important. But this is my Tori up and running now, just with one command. And so this is my indexer, and it's exposing the GraphQL and just like the raw endpoint. And so we can go to the GraphQL, check it out. Actually, yeah, I'm about to swap Windows. One sec. Yeah, so now we're exposed in here. And this is moving Windows out of the way. So you can see here my schema. The GraphQL, like at runtime, generates your schema based on your models. And so you can see here, I've got my player model, I've got all my operators that I can do, and I've got my tile, and I've got my connected edges and whatnot. And so this is really just, I mean, if you use GraphQL, it's just GraphQL. I mean, GraphQL is okay for building games. It's more for like kind of testing things if you want to build like dashboards and whatnot, which is cool. You can do that with this easily. And so that's GraphQL. Flip back to my get this for a second. So we've got Tori up and running. What I need to do now is go into my client. I just install it. Everything's installed already. Oh, I got something running. And so I've got this installed now. And so this is the client that I just spun up. It's a very basic client, but I'll spawn. Cool. So I just click spawn. I'll go into the JavaScript code in a second. But what it's doing is it's trying to call the spawn function in my contract. And you can see here, I've got an error. And I've got a not writer error. I mean, there's a lot of topics in Dojo that I don't really have time to like cover everything. So I'm trying to just kind of do a high level stuff. You're gonna have to go deeper into this, but one of the important kind of concepts is like authorization. And so we'll just do a quick hot swap to my Figma. Yeah. Here's a model. So here's my player model actions world. So if you think about like composable games, like there needs to be some kind of like parameters to like if I deploy a contract, I don't want to allow anyone to like touch my state, right? Unless I give them permissions to do it. Otherwise, it'll be total chaos. And so the way Dojo works is that what I can do is I can call the world with a like authorization. I can be like auth transaction. And what the world does is that it will store like a permissions of a user being able to call the actions contract. And then in the actions contract being able to mutate state of the player model. And so this is like this line here is like right now it's permissioned. I don't have access to do it because I haven't set it yet. But when I do set it, it means the system, the actions contract can then update the player model. And so this is important, like tiny little concept that you just need to be familiar with. And so to do that, it's quite easy. There's a scripts folder here. And so in the scripts folder, it's a little sh script, but we are, this is like a helper function really. And we're just kind of getting the manifest and we are getting the world address. And then we're running a sozo command. This is the sozo auth command, and we're granting writer access of the model, the actions contract, and we're doing the same thing with the tile. And so this is going to allow the actions contract to change the player tile. And so I just run that script. Now I've run that script. This will obviously get quite large with like bigger apps. Now we're back here and I spawned and transaction worked. And now I've kind of been exposed this grid. And so this grid is just 0 to 14, 15 by 15 rows. And if you remember, in the tiles, I did X and Y. And so, first number is X, second number is Y. And I can just flip between blue and red. And I can paint these tiles with a clicking. So I don't know, maybe someone can turn this into like an actual giant board you can paint, something with. But right now you can just paint these things. But I'll go into the code now. And so this is what's happening here is I'm interacting with the world we created. I'm sending a transaction and then it's returning the state and it's storing it in here in the client. So this is just a basic little Vite app. I highly recommend people to use, like, if you're going to do JavaScript, either do like vanilla JS if you're good with that, or I suggest use a Vite React app. I do not suggest using Next.js or kind of a framework with all the bells and whistles and server-side rendering and stuff, because you just don't need it, and it just adds clutter and kind of gets in the way of trying to write a game. I've been down that road before. So best place to start is just a very basic little Vite React app, which is what this is. There's a bunch of templates in the Dojo.js. So Dojo.js exposes here. We have a bunch of packages that we expose, and this is what we use for this little app. So this is a very basic app. I got one file. I've tried to make it as basic as possible because we can probably get caught up in JavaScript all day, but yeah, everybody knows how it is. And so this little app, where should I begin? Actually, I'll go through some directory structure. And so there's this Dojo folder, and within it there's a use Dojo hook. There's Dojo context, which is just kind of setting up the account. It's not that interesting, but you could have a look at this later. Just sets up a provider. There's system calls, which just defines like how I'm going to kind of call my world. And I just put it all in a single file. And then there's create client components, which is part of the Rex framework. And then within here, we've got contract components, which are, yeah, I mean, there's a whole other subject of going down this state library, which is called Rex, but I really don't have time to kind of explain all of it. You'll just have to trust me on this. But yeah, it's a state library, and I define like the components here. And so these are like a one-to-one representation of the actual models that we defined in our contracts. So you can see here, address, player, last action. They're all defined here, and same with the tile. And then this allows us to have like a very manipulative state throughout our app. And then just a note, I say generated, but this is still kind of being worked on. In the future, this entire folder will be generated with one command. But it's still kind of a work in progress. So just keep that in mind. If you are like a super TypeScript guru or you fancy yourself, we actually are looking for someone to really help with the Dojo.js toolchain. So if you do fancy yourself like JavaScript nerd, reach out. And yet, no, this is just a generated client that as well, which is based off the Dojo provider, which is kind of like this exposes all the Dojo functions. Yeah. And then there's this big setup file, which, yeah, there's a lot of stuff going on here, but you can worry about that later. But what we should focus on is just like the high level stuff right now. I mean, you can just imagine this is just a simple little use Dojo hook, and we are importing the client. We're importing the components that we want to use and the account, and then we are fetching the player through the use entity query, which is another Rex kind of function. We're getting the component value, which is a way to kind of get the reactive state of the player based on the components that we've defined. And then we are just making a grid, and we're rendering the grid and the buttons. And you can see here, this is the spawn function that I called. Pretty basic, but it's just sending the account to the spawn function, and it's returning if the players are. And then in the tile itself, we're doing something simple as well. Because it's a cell, we've got the X and the Y. We are getting the component value from the keys. We're getting the tile, and then we're just rendering those values in here according to the color that they are. And so that's what happens when I click a color. It paints the color, encodes it into a big int, and then if it's changed, it returns it and just displays it. And so these little client functions and these component functions are how you can define a very like complex little app quite easily using Dojo. There's a lot of like little bits and pieces in JavaScript, but I don't want to make this like a full JavaScript lesson because there's a lot of stuff. But I mean, this is probably a good chance to kind of take some questions, and maybe I can, if anyone has any like things they want me to show them extra, I can show them. But yeah, I pretty much showed like an end-to-end here and an end-to-end Dojo app working and synced. So Katana working, Dory working, contracts, client, and then you can imagine just this multiply the complexity by 100, and you have like a full-blown game, all the bits. There's a lot of stuff here. I think it's better if I just be kind of brief in this part and just try to just do the high-level concepts because there's a lot of stuff. But yeah, I mean, I think what everyone should just get out of this is that like Dojo isn't like this like crazy complex thing. It's just a bunch of tools that help you build games fast using kind of the things that you're already familiar with. That's really what it is. Well done on getting to the end of that session. There's a lot to take in around Dojo and Cairo and on-chain gaming and autonomous world. But my advice to you is just to try to consume as much of the information out there. Go and look at all the existing games and projects, not just in the Starknet ecosystem, across the on-chain gaming ecosystem in general. Feed off other people's ideas and stay curious. The best place to go from here is dive into all the Dojo repos. Go to Awesome Dojo, the kind of collection of open Dojo projects right now, and just go to try and build something. And try to build something simple. Probably try to build the simplest game you can to begin with, and then try to layer up complexity after that. And this is coming from experience. All right, goodbye.